Hello and welcome to App2Container session. My name is Ashish Bhatia and I'm a solution architect with AWS. My primary focus is on .NET and enterprise application modernization. In this session, I'm going to show you how to use App2Container to containerize applications. Here is the agenda that we are going to cover in this session. First, we are going to review containerization, its architecture and benefits. Next, we are going to talk about App2Container tool and deployment options leveraging the tool. Then we are going to review the App2Container workflow. And finally, we are going to go through a demo. Let's start with some of the details on containers. First of all, containers include everything needed to run software, including files and libraries. Container combine the libraries of an application or microservices into one deployable unit. This makes them very easy to deploy and portable. Also, multiple containers on the same machine share the same operating system kernel. At the bottom, you have the infrastructure. Think of it as a hardware. The next layer above the host operating system contains the operating system kernel. The next higher layer is the container manager, which typically supports multiple containers. Think of Container Manager as a software to automatically create, deploy, and scale containers. In addition, container management includes orchestration and scheduling of containers, security tools, and monitoring. So, why are companies adopting containers? First is to accelerate software development. Containers being lightweight and portable makes it easier to deploy code through new software pipelines. Secondly is to build modern application. Modern applications are shifting to becoming cloud native and adopting microservice architecture. Containers are a perfect way to encapsulate these pieces into portable units. Also, containers can be used for existing applications without any refactoring. This allows applications to be more portable for migration to public cloud and also retrofit the application into newer development workflows. And finally, by leveraging containers, it works very well by integrating it with CI/CD pipeline. CI/CD over containers makes shipping of code easy. It enables enterprise to maximize their efficiency and innovate faster. AWS App2Container is a command line tool that you can use to containerize Java or .NET application. Also, the tool will generate deployment instructions for running containers on AWS. Tool supports three different deployment options. A, you can run this on Amazon Elastic Container Service. B, it can generate instructions to run this on Amazon Elastic Kubernetes or EKS. And lastly, you can also run this using App Runner. One of the benefits with using the tool is that it provides a nice way to containerize legacy code and it does not require having access to the source code. Also, the tool assists in containerizing applications at scale and wrap the best practices to generate deployment files on multiple platforms. App2Container supports running on both Windows and Linux platforms. Also, you have the option to run App2Container directly on the application server that are running your applications, or you can use a worker machine to containerize this. The option to running this on a worker machine is what we'll cover in the part of the demo, and I'll provide you with detailed set of instructions on how to configure and set up the worker machine to run the App2Container commands and containerize the application that is running on a different server. Also, App2Container does not need access to the source code for the application to containerize it. The goal here is to help the customer not only containerize applications, but to do that with minimal effort. App2Container integrates well with other AWS services. Here are a few examples. Tool uploads a container image to ECR, and this is what we are going to show in the demo too. If ECS deployment option is selected, App2Container tool can generate task definition and service. On the same lines, if you choose EKS option, the tool can generate the pod and deployment YAML. Also, you can deploy container images using App Runner. On this slide, we are going to review the deployment considerations for running the tool. The first thing that you need to do is to figure out where you're going to run the containerization process. As mentioned earlier, there are two different options available. Option 1 is to install App2Container on the same machine which is running the application. This option is relatively simple and the dependency is on the Docker engine. If, however, You are unable to install Docker engine on the server that you're going to be analyzing, you can set up a worker machine that can do the work. Few examples where a worker machine may be more suitable are if your application servers are running an internal data center and they don't have internet access. Another example is when you have multiple applications running across different servers. Installing Docker on the worker machine would be relatively much more simpler than installing and configuring Docker on all the different application servers that are running your application. Let's talk about the workflow of App2Container. We will look into each step in the demo shortly. At a high level, App2Container contains 4 steps. The first step in the process is to discover the running applications in your server by creating application inventory and then analyzing them. The next step is to run extract and containerize to retrieve all application artifacts to the worker machine. This is with the assumption that you are running the App2Container on a worker machine. The third step in the workflow is to generate deployment artifacts. In this step, App2Container pre-fill key values in your deployment file based on your profile, the application analysis, and best practices. In this step, App2Container can generate the deployment file for different container management environment, for example, ECS, EKS, and AppRunner. The last step in the workflow involves deploying your container images. Here, App2Container will move the image to Amazon Elastic Container Registry, that is ECR. Also, App2Container can generate deployment files. For example, if ECS option is selected, tool can generate files to create service and task definition. If EKS option is selected, the tool can generate service and pod YAML. In addition, App2Container creates a master CloudFormation template for you to automatically deploy and configure all the required resources in the cloud to run the application that you just containerize. Let's look at the demo. To start off, let's go through the steps to download and configure App2Container. For this demo, I already have zip file downloaded. It's in my downloads folder. The zip file contains the installed PowerShell script that you can use to install on your machine. It's right here. To configure App2Container, you need to open up a PowerShell command prompt and run App2Container in it. The first thing it asks is for workspace directory. This can be any folder on your machine. For this demo, I have it under C, App2Container documents. For AWS access, you can use an instance profile to pass an IAM role to EC2 instance. App2Container detects if there is an instance profile associated and can use this role to access AWS services. As you can see on the screen, in this scenario, the App2Container was able to figure out that the instance profile that is associated with this worker machine is this, and it prompted me if I would like to use this instance profile role to access AWS services. So I will select yes. The next option it prompts is for AWS region. For this demo, I'm going to be using US West 2. App2Container store deployment artifacts in S3. Also, it creates and deploy application containers. For this demo, I already have an S3 bucket that I have pre-configured. So I'm going to be using the same bucket, which is App2Container enablement. The next option, if you would like to report usage metrics to AWS, I will say yes. The next option prompts you for automatically uploading logs and crash information to AWS. We should select yes for this option. This helps improving the tool. And the last choice is whether or not you should require images to be signed using Docker Content Trust. Docker Content Trust, it provides the ability to use digital signature for data sent to and received from remote Docker registry. It's really a way to validate trust on the Docker image itself. The default is no, and I'm going to go with that option for this demo. So at this point, you have configured your App2Container tool on the worker machine. After you have completed setup and initialization task on your servers, App2Container helps you gather a list of running applications and perform analysis to determine what should be included in your application containers. There are multiple steps involved. For this demo, it is a simple web application that goes to the database, pull out some different data items, including the category, and displays them on a web page. So let me show you what the source web server application looks like. So here I have an RDP session established to a server that is running my application. The application is running within the context of IaaS under default website. It's running under port 8081. And if I bring up the application in a Chrome window, this is what it looks like. Our goal here will be to take this application, containerize it using App2Container, and then run it using ECS. Here you can see it is basically a simple application running Unicorn Web Shop, displaying a list of items that are getting pulled from the database. Next, we are going to run the App2Container inventory command where App2Container can discover this application. So let me switch the context back to go back to the worker machine. And at this point, I'm actually going to run this command. We need to provide the IP address of the machine that is running our application. When we run this command, App2Container detects the applications that are running in IaaS. It also detects the Windows services that could be configured as dependent application component. Now, it may take few seconds for this to capture the information. Okay. So at this point, the remote inventory has been retrieved successfully. So if we go back to our folder, and here you can see for every server that we have defined, it's going to create a separate folder for this. If we double click on this, there's going to be another file called inventory. And if you open this file, it gives a unique name for each of the application that I discovered. It provides a site name, which is a default website. It tells us what ports it's running on and which application is running that website on. The next step in the process is analyze. When you run the App2Container analyze or App2Container remote analyze commands, App2Container will analyze the application component that you specify with the application ID parameter. So let's see what it looks like. We need to provide a target, which is the IP address of our application server. And we also need to provide an application ID. You can grab the application ID from the inventory.json file, and let me show you what it looks like. So this is the inventory.json. Copy and paste this application ID, and you specify as an input parameter. This may take a few minutes. What this does is App2Container will create the folder structure for the application component inside the App2Container directory. It will also produce analysis.json file and save it in the new folder structure, along with other artifacts that are required for containerization. The analysis is where you begin to define your container structure in App2Container. App2Container containerize command performs the following tasks for the application. It generates a Docker file and a container image based on the settings that we had defined earlier in analysis.json. Secondly, the tool automatically creates a deployment.json file. The file will be placed under your workspace folder. For this demo, we had defined the workspace as C App2Container documents. Let's take a look as to what this file looks like. So here, I'm actually navigating to C App2Container documents. App2Container at this point have defined a new folder for this application ID, the one we are containerizing. And you could see here there is a new file called deployment.json. Once you open the file, you will notice there are various configuration settings for each AWS service. App2Container pre-built those settings for you, but you are free to update those settings to adapt to your environment. You can update the file to specify if you would like to deploy using ECS, for example, or you can even actually say if you would like to take advantage of EKS deployment. You also need to specify the VPC ID. At this stage, you should have your container images ready. We can validate this by running a Docker images in the PowerShell. So let me run that. And you can see there is a new image that got created with the same application ID. It was built 2 minutes ago. So the next step would be to go ahead and deploy this application. From a deployment standpoint, you can think of this as a two-step process. In step one, we will go ahead and generate the deployment artifacts. And in step two, we will deploy the resources onto AWS platform. Now for step one, which is to generate the artifacts needed to deploy your application container in AWS, App2Container pre-fill key values in artifact based on your profile and best practices. This is what we had looked earlier in analysis deployment.json file. Now on this file, we need to set some required parameters. Now for this demo, we are going to be deploying this using ECS. So let me show you where you're going to specify this. You're going to come to your workspace folder. You will see your application ID. Open up a deployment.json file. You need to set for ECS deployment saying create ECS artifacts to true. In addition, you need to specify the VPC in which you're going to deploy the resources. You can get the VPC ID by going to your AWS console. Go to your search box. Now in this account, I have 5 different VPCs. I will pick a VPC where I would like to deploy this resources. So I would like to deploy this in this target VPC. You can copy and paste the VPC ID. And let's go back to our worker machine. And you paste your VPC ID here. Oops, I think I didn't get that. Okay. So at this point, you can save this file and close this out. Come back to your PowerShell, and at this point, you can run another command called App2Container generate app deployment and pass in an application ID as a parameter. The process will take few minutes. Now with this command, App2Container will do the following activities. First, it's going to create an ECR repo and move your application container images to the ECR repo. And we can validate this once the command finishes by going to the AWS console. In addition, since we specified ECS deployment as set to true, it's also going to create an ECS task definition and register with ECS. At this stage, your application container image is already moved into ECR, which is Amazon Elastic Container Registry. In addition, App2Container creates a master cloud formation template for you to automatically deploy and configure all the required resources in the cloud. Let me show you where the master template is defined. If you go to your workspace folder, and for this demo, again, we had it under C App2Container documents. Click on your application ID. At this point, you will see a new folder called ECS deployment. If you click under this, you will see a new file called ECS master. This is the master cloud formation template that has been spit out for you by the previous command. Now you have two options to deploy this. You can either actually run this through a PowerShell with a command like this, which is AWS Cloud Formation Deploy, and you pass in the Cloud Formation template as a parameter. Or you can take advantage of the AWS console and specify the CloudFormation template as an input file. Once you run this command, and if you go back to your AWS console and go to CloudFormation stacks, you can filter it by an application ID. You will see a stack has been created with this name. You will also notice nested stacks are triggered by the main stack for each deployment. For example, a separate stack for ALB and ECS cluster. And you can see the triggered events under Events tab. It's completed. You can go to the ECS console and validate that a new cluster is there. Here you can see a new cluster was created after the CloudFormation template was completed. Within a cluster, you're going to see a service, and within a service, there's going to be a task definition. In addition, the service was exposed using a load balancer. So here is a reference to a target group. And once you select a target group, you should be able to get to the load balancer. And there is a public DNS entry that's defined for this load balancer. If you copy and paste this URL into a new Chrome window, you should be able to see the same Unicorn application that was running on your on-prem server. And at this point, we have been able to containerize it and run this under ECS. We went through the 4-step process of App2Container. The step number 1 is where we discovered the applications that are running on the application server. We analyzed the application. The next step was to extract and containerize the application on the worker machine. The next step was to generate and create the deployment artifacts. And here, App2Container offers multiple options. For this demo, we selected ECS as an option. And the last step was to deploy the resources onto AWS Cloud. As you can see, App2Container can be a powerful tool in your toolbox to containerize applications. We were able to containerize an on-prem app and deploy to AWS in an hour. Also, as you saw, it was pretty quick and relatively painless to do. Thank you for joining me in this demo.